Hello everyone, this is tutorial 12, Prismatic Machining. First of all, you might be wondering why my CATIA looks a little bit weird. I just wanted to show you a couple of things that you can do now that you are getting more into the intermediate stage to customize some of the things. One of them is actually changing the dimension of the icons. So you can go Tools, Customize, and you can actually request that. So there are different things in here. One of them is in under options is large icons, and you can say like this one, I made my icons 5 times bigger. So of course we are all used to this one, but let's go ahead and just for the sake of showing it, make it 1.5 times. And now CATIA is opening up, and you will see the icons 1.5 times the usual. So I'm gonna, like, just to show you just a little bit, this is how it would work. So let's return it now, or else I will be very confused all along. I'm gonna return it to the usual, which is 1. So close and CATIA. And as CATIA is opening up, there is another option. If there is a certain workbench that you use more than the others, you can actually put it part of your favorites. And when you open CATIA, it asks you if you want to go ahead and get started with it. So let me show you first of all like how it appears. You see, like I did put Prismatic Machining, which is the one that we're going to be using today as my favorites. And if you can go Tool, Customize, in the Start menu, the first one, so if I remove now Prismatic Machining, it will disappear from here. So Tools, Customize, let's say the one that you use the most are Assembly Design, a Composites Braiding, and so on. You can actually have them directly listed in here. So this is one of the things, like this is sometimes how you can customize your CATIA. I am not a big fan of the favorites just because I use like almost all of the different workbenches, but this is, and you've seen this one, toolbars, how you can like restore, reset, and so on. Alright, great. Now that we've seen that, let's go ahead and get started with today's tutorial. So today's tutorial, it is about a introduction to prismatic machining. And we are going to first of all make sure that we create the reference elements, we design the part, and so on as usual. Something else I want to show is the creation of a folder. Make sure that you actually create folders with a good structure, because when you finish, and I'm going to show you at the end today, if you just send the process file to someone, they will not be able to open it. You need to send the process, the parts, the product, everything that you need as well. So having a good structure of the folder is actually very important. So let's go back to CATIA. Let's go ahead and start with part design, and we're going to start with our billet. So as you know by now, I have the habit of saving from the get-go. So let's go to desktop and tutorial 12 parts, and we're gonna save the billet over there. And let's go ahead and get started. First of all, we are creating a geometrical set as usual to create the reference element. References. Alright, so it's important to connect things with respect to the different elements. So basically what we need when it comes to prismatic, we need like a safety plane, we need the tool origin, we need the programming origin, we need the machine origin, and all of these different elements. Let's go ahead and start with the first one, which is the 000, and that would be our programming origin. Moving to that, we're going to create the machine origin. So we're going to create it at 2 feet by 2 feet by 2 feet. So this is gonna be our machine origin. So it would be useful from the start to actually name your points so that you don't get like mistaken. So programming origin, machine origin, and we can actually press the zoom all in so that we can see it. All right, perfect. Let's move along. So now we have to create a retract point. We're gonna do it along Z. So make sure that the reference point is a default, the origin, because sometimes you can create, so let's say if I click the default one, this one. So now all the dimensions are with respect to that point. So make sure you're doing it, the reinforce element, with respect to programming origin. And we're gonna do a 0, 0, and 4 feet, 4 inches. 4 inches, and this is the tool retract. Alright, so we're gonna create a safety plane that is an offset of the XY plane by 6 inches. And this is gonna be our safety plane. Alright, so now we have all of our construction elements. Perhaps let's go ahead and change the graphics on them. So I'm going to put the programming origin something as, let's put it something as green. I am going to put the tool retract yellowish. This is like watch out, this is where you go to and from. And I'm gonna put the machine origin reddish. This is where we go to change tools and we go back home. Alright, safety plane. Let's go ahead and make it, I don't know if we can change this one. Let's see if we can make it yellowish. Yep, we can. So that's cool. And I am going to hide the other planes and file save. So we can leave perhaps the XY plane. This gives us a reference to start building our part. All right, perfect. So this is where the machine goes to change the tool. This is where the programming will go up to. This is a safety plane, and this is where if you want to swap the tools coming back and forth. And this is where the programming will be from. So this will be the surface of the programming. Let's go ahead and start creating the billet and the part creation. So the dimensions that we're looking at is a centered rectangle of, it looks like it is of 4 inches. Let's verify that. So we have XY plane for 4 inches, and then it is extruded 2 inches, obviously in the negative orientation. All right, so that's fairly simple. We're going to click a sketch. We're going to create it in here. We're going to go for the centered rectangle, and we are going to make sure that we connect the different elements with each other. We're going to make them equal, and we're going to make that equal to 4 inches. So if you are bothered by the fact that it is transforming it to millimeters and whatnot, you can actually go to tools options and go to parameters, units, and change that to inches. Like this, it will start showing you everything in inches, and like this you won't be disturbed by this fact. So now the next thing is we're going to extrude it. If I recall well, it's 2 inches negative, obviously, so we're going to extrude it. Aha, that's good. So I forgot to put the part body as the active element, so it was creating things in the references. So I just moved it, and we are going to take the sketch in the opposite orientation and create a 2-inch part. And this is our billet. Save. This is our billet. Now we can move on to create our part. So the best way we talked about it to create the part is to actually, let's make sure, hold on a second. So yes, so the best way to make a part is File, Save As, and you create in here a part. Make sure when you do that to change the name in here, like Properties, and make sure you change that to Part as well. And File, Save All. So what's good about this is we know the boundaries of the part that we can create, and we're gonna do things a little bit differently today. Instead of creating the part right now, what we're going to do is we're gonna create the assembly, and then we are going to double click and modify our part a little bit to have the part. So I'm gonna close in here. We're gonna start mechanical design, assembly design. Insert existing component, we click on product, tutorial 12, and parts, and we insert both parts. Properties, you know it by now, naming is very important. Product RH, manufacturing assembly, and right click, snap automatically. So let's move the parts and make sure that we snap them to each other the right way. So the way that I'm gonna do it is I'm going to put a fix on the billet itself, so the billet will be fixed, and then we are going to make a coincidence constraint between the two centers, and then we are going to make a distance or parallelism, or so if I do it right now it will be good, but this can still rotate around. So perhaps what I will do is I will put an angle between this face and that face, and I'll make it 0, and so these points are coincidence. This should work. Control U, perfect. Control U makes them snap on each other. Reframe on. This show me both parts. Now I can hide the constraints. I don't need them after this. I can remove the compass and remove the snap automatically. And what we're going to do is the part body, we're going to give it some transparency and some bluish color. And like this, now we can see if if we change the part. So File, Save All, we save everything. Oh, we did not save yet the product, so let's start with that. Save As, go to Product, save it, yes, and File, Save All. Perfect. Now what we can do is, we're going to do is I'm going to hide the billet for a second, and we are going to go to the part body to change in the design of what we have. The first thing is, let's go ahead and see. So the first thing is we're going to do some surfacing operation and remove 0.1 inches. The way that we do it, we're going to click more, and in this second dimension, so I'm going to demonstrate this one. So I'm going to put -1, and you're going to see how it's going to move, like it's going to become, this length is going to become like 1 inch. So this is what happened. Now we don't really want to remove a whole inch, we just want to remove a little bit, so we're going to remove 0.1 inch, and you see a little bit how much it's going from this plane to this plane, and this is to do a surfacing operation at the start. So that's the first thing. The second thing we want to do is we're going to create a 3x3 pocket. So we're going to click on the surface. We can, so we don't want, we click, so if you click fit all in, it will fill everything else. If you click right click reframe on, it will bring you back to this point. So in here, and we can do, so I'm going to show you another way to actually like set everything else to 3 inches. You can select control and right click equivalent dimension, and then say, hey, they are all 3 inches. So as you see, every time I demonstrate a different way to do things, and nothing but practice will help you, you know, get how the best way to do it. We're gonna do a pocket of 0.5 inches, preview, and then we're going to edge apparently only one corner and set it equal to 0.2. So this is our part. If I do right click now on here and change this to something greenish, this is what we want to achieve. Yeah, let's leave the screen for a second. And now unhide this one. This shows us our part, our assembly. We're gonna move from this billet to this one, so we're gonna have a surfacing operation, we're gonna have some pocketing, and so on. File save all saves everything, and we are ready to move to the next stage. So now is the next stage. Basically, there are different ways. So actually, there is something useful that we can do before we move forward, which is I'm going to move in here, and actually we can create what we call an access system. So let's make sure we are in the billet, yes, and you can actually create an access system for manufacturing. You can say, hey, I'm gonna use an access system, and so like this is XYZ, they can stay the same. So Z is always according to Z convention, it's gonna be out of the part itself. I click OK, and this creates for me my programming access. So we can, it's very, very important to create different access, and it is really becomes very, very useful once you have several parts. Like this is for complications. You can have create a reference in here, another reference there, and try to coordinate between them if it's needed. All right. So now we have everything we need. We can click Start, Machining, and Prismatic Machining, which is what we want to do today. As you're discovering, as we're doing these manufacturing, it's always the same. So I don't know where did the 3 go, so F3. So for some reason it was hidden. Most probably when I used it last time, I was taking a picture or hiding it. So if you press F3, it shows back up, and you can actually move this and so on. Alright, so it's always the same. You double click part operation, you define your machine, you define your different elements, and then after that you start doing operations. It's always whatever manufacturing you're going to do, it's always going to be the same. So let's go ahead and double click on part operation. So this is the part that we have, and let's go ahead and see. So let's start selecting things. Let's select this is a 3-axis machine. So it is already showing a home point at 3.90. So I'm going to put it at 4 just so that it matches what we wanted. Tooling. So basically you can use a starter kit. When you are manufacturing at a facility, you will have the real tools set within your tool, and let's go ahead and set up a post processor, pick hearth, and I'm going to select, actually you cannot select a lathe. Let's see if, so ICAM, it is suggested to use the ICAM inches, so we're gonna go ahead and use it, and so on. So this is good for the machine. Now the references, so we can click on this one, and instead of worrying, you can select here and not even look at the part. You can come in here and select the access system that you've already defined. So now we have to select the billet. Since we are on the billet, let's go ahead and do that. So, and then the part, we're going to select the part. Safety plane, it was very clear in here. So in here you can also select fixtures for simulations if needed. And there are these positions. These are for simulation only, and sometimes, like for example this point, if it was somewhere else, you could see like in the simulation like some stuff being removed more than it's supposed to be. These numbers look good for me, so I'm gonna leave them at what they are. Alright, so we have defined the part operation. If we needed to manufacture the same part from the other side, let's say, perhaps sometimes you create a new manufacturing operation, or you can literally create a new part operation, as if you're like creating a part on different machines. This can be really useful at sometimes. All right, so this is where we are right now. I'm going to hide the billet, so because we don't really need to see the billet, and we're gonna be focused on this part. And actually within this part, because we like some of the things we don't need to see them, I am going to, if I find it here, I'm gonna hide this plane. We can actually hide all the reference elements. No, not really. We need them. Programming origin, machining origin, tool retract. We need to select them. So actually, you can hide them, but you still can select them. So this is if it's ever needed. All right, cool. So this is to avoid confusion. The machine origin is somewhere here. Okay, but the view was letting us. I'm going to change that green because it's very confusing with this one to the darker green. Alright, cool. Now we're good. So let's go ahead and get started. The first thing, the first operation we want to do. So in here you have the different operation, the standard operation. So you have a pocketing, you have a facing, you have a profile contouring. Come on, show up. Profile contouring, and you have other operations. This is one of the operation that is super useful if if you have a very complex part. You start with a general roughing. We always are going to have a roughing operation followed by finishing, and so on. The first thing that we are going to do as an operation is so let's make sure it has to be a facing operation, where we're going to do at the top. So we're going to click on facing, and we are going to select the manufacturing program for it to select it. And this gives us into the different elements in here. So we can select the, so this is always a geometry selection in here. And there are options, like there are offset options and so on. This is the strategy. I'm going to talk about this in a second. This is the tool selection. I mean, definitely this is wrong, but we're going to talk about it. This is the automatic computation of like feed rate and speeds. And this is the tool approach and retract. As you can guess, this might be like it's taking it from the safety plane, but you can, like, we can easily change the stuff. So let's go ahead and get started. Usually you always start with the geometry selection. So we're going to select the top face in here. Now, keep in mind the way that I've selected it. So there's so many wrong selections, and you're going to see the right one in a few seconds. But let's go ahead and just show you what's going to happen in here. Right now, this is the operation that's taking place. So we are facing it inwards. I'm going to click on the video. This is how we're starting with, and we've removed this. All right, let's start with the wrong selections. First of all, you never ever do facing with an end mill. You actually have to click on the face mill itself. These are the types of tools that are useful for facing. So that's the first thing, and you can see from here like a couple of lines. And all right, so you can see how it actually moved, and we did the facing that we had. All right, good. Now the second thing here, and this is not wrong, but this is a strategy. You really want to take a look into how you want to do. So you can do back and forth, you can do one way. So let's see them. This is back and forth. So I'm gonna go ahead and play them slowly. Actually go back all the way, and now, so one, like, you see how it's going back and forth. All right, let's see the video for the back and forth. All right, cool. So you're getting the hang of it. The second one is, let's go ahead and select one way. Basically, one way it's just gonna, the machine is gonna come, like you can see it. It's gonna come and it's gonna lift and it's gonna move. So you can see it from here. And it goes just one way and goes back just one way. So you can see it in here. And these selections, they actually influence what you end up getting as quality of manufacturing. All right, cool. So, so this is good. Now the final thing is that so there are so many things in here to pick from. You can change. So actually you can decide like you want only one level. You can say, hey, no, I wanted two level, which means like I'm gonna show it to you, which means the manufacturing is going to come up and down two times. Well, it looks like it didn't do it in here because the maximum depth of cut is 0.02 and we're just like barely removing. So you can actually change in here maximum. Like you can say, like we are removing 0.1, I think. So the more that you reduce it, it's gonna create more levels, and you're gonna be able to see that. So these are different, and you can do like finish bottom or finish pass and so on. So these are different operations. The last thing I want to do is, so it is going up and down from the safety plane, which is fine. I mean, we don't have to change this, but we can actually like do perhaps only actual or another operation. Like let's say built by user, we can delete all of this and just go up. Actually, I want to go to a point. Is this, no, add motion to a point. Let's see if this takes it. Even though it's on the side. Yeah, that was not a smart selection. Well, actually, it did go to all the way to the point. So, and then you can also click, you know, sometimes different approaches are useful. It really depends. This one, we really want to attack it from the top. So we are going to go back with this. Actually, I'm going to back with this to go to a plane, and I'm gonna make it go all the way to the safety plane. And this is good. So we have what we want. Okay, so last thing, I want to change back the strategy to inward helical, and these are the levels in actual. We can remove it, we don't need to see it, and voila, here we go, perfect. So we play the video, it does the part. It can show you like the thickness now, it shows you how much time needed, and you can associate video and save it and click OK. Now we have our tool change to a face smell, and we did our first operation, which is a facing operation. So as you can guess, everything is going to be the same. So the next thing we want to do, now make sure before you select on another operation, so now we're going to do pocketing, right? But make sure before you do that, pick the facing operation, because if you don't do, sometimes it might do the pocketing before the facing. So like if I do that, it's going to come down after it. First of all, observe in this location how when I change to a end mill, it's gonna split and it's gonna become under another operation. A tool change means the machine is gonna go to the home, change the tool, and come back. So there are different types of pockets that you can actually select from. So you can see in here, like if like you can see the options. So you can say like it's an open pocket. Like look, I'm gonna click on it. So actually this is not an open pocket. This is a closed one, and this is how it looks like. So we can click in the middle at the bottom and here, and it will automatically find all the others for us. So you can actually even click on this one and say this is the top. I mean, you can select whatever you think is right, and you can play it around and change the dimensions and so on, and keep trying until it figures it out. Strategy wise, the same as discussion we've had before. So in here it's gonna go down, I forgot how much we went depths, approximately a half inch perhaps. So in here, like if we have number of levels, if we have certain things, we're gonna play around with them and we will see what's gonna happen and so on. So outward helical, concentric. So let's see first of all if it works. So it looks like we have so many levels going down. I don't think that's correct. Yeah, we do have a lot of levels. Like we do have like 26 levels. So perhaps if we put this at 5 levels, let's see if that changes. Yep, so now we're only going 1, 2, 3, 4, 5. And we click OK. We can actually see the video. And if we are a little bit so this is important to know that you are only going to get in here the smallest you're going to get, even if it's straight. So look at this once again. I'm going to save the result. In here we don't have a filleted, but there is no way you're going to get a straight edge in here because the tool itself. So if we actually go ahead and position ourselves like this, like if we look at this in here, okay, the tool, I mean, you're going to place a circle in here, and that circle, let's see if we can actually like just demonstrate a little bit the concept here. So in here your tool has a certain circle. In here your tool is going to come to a point in here where it is tangent, and it creates the circle. So that area in here, there is nothing you can do about. The only thing you can do is make your tool smaller and smaller and smaller until you're capable of getting closer to this. So if we want to actually change something in here, we can come and say, you know what, this tool is too much, so let's make it first of all a completely end tool, and let's change it to, I mean of course it has to be, you really have this tool, and we come in here. Look at the, in here the tool can do this circle to follow this profile because we want it. In here it's only gonna get tangent in here. So now the fillet in here is gonna be much smaller. So let's go ahead and see that, and now you see what happened because we changed the tool. Alright, this is good. So these are the different elements of this tutorial. I don't think there is nothing else besides generating the G code. So we have generated the pocket, the facing, and the last thing we want to do is actually create the NC code. So we're gonna generate the NC code. So let me first of all save. That would be useful before we actually proceed with this. So let's go ahead and file, save as a process, under process, and we are going to call it right, brcrh. This is T12 V01. Alright, cool. And now generate interactively. NC code, this has been taken into account. NC code, we're gonna store it at the same location, and let's execute and go see that folder. So there are no errors, which means we've been capable of generating the G code the right way, and we generated at the same place as the process. What we can do is cut this and put them in here, and now this is cat NC code, so we can open it with a notepad, and you can see, just open it. Oh, it's open on the other screen, and now you can see this is the G code, and so on. So this is the end of this tutorial. This G code is actually very useful for you to read, and it shows you a little bit like a tool change, machine setting, some feed rate going to certain points. There's different geometric motions, and then you can see the manufacturing starts in here because the feed rate has been set low, and we have like linear motions like G1 and so on. So actually this is the end of the tutorial, and thank you so much for listening to me.